Our first problem is determining velocity or acceleration. A car on the highway drives down at constant speed, while another car drives down the highway with increasing speed. Draw and compare graphs. So for the first car, as it drives down the street at constant speed, if I can take two radar guns and point them at different parts of the street, I can assume that it maintains the same speed, which is 15 meters per second. With velocity is equal to the change of speed over time, we can assume that the velocity of the car maintaining constant speed is constant, which is a straight line. With a car that has an increasing speed going down the road, the car going down would start at 50 meters per second and would end at 75 meters per second later on. With acceleration equals to the change of velocity over time, we can assume that the velocity versus time graph of the car goes up at a positive rate. Our second problem is calculating kinetic energy. A roller coaster cart has a mass of 120 kilograms and goes down the ramp at 12 meters per second. Assuming the ramp is frictionless, how much kinetic energy does the car have? Based on the problem, 3 cars including 5 passengers weigh 128 kilograms as they go downhill at 12 meters per second, assuming no energy is being lost to friction. Based on the problem, we can assume mass is equal to 128 kilograms and our velocity is equal to 12 meters per second as we solve for kinetic energy. Applying laws and formulas, kinetic energy is equal to 1/2 mv squared. Replacing the m and v variables in the kinetic energy formula, the kinetic energy of the cart going downhill is 9,216 joules. Our final problem is elastic collisions. Two men are jousting. Neil has a mass of 53 kilograms and a velocity of 3 meters per second. Jerrel has a mass of 48 kilograms and a velocity of 5 meters per second. Find the final speed of the elastic collision. Based on the drawing, two men on horseback are charging at each other with lances to hit their opponent in the chest, knocking them off the horse, making it an elastic collision. Based on what we know, Neil has a mass of 53 kilograms and a velocity of 3 meters per second, while Jerrel has a mass of 48 kilograms and a velocity of 5 meters per second, as we solve for our final velocity. With total momentum before and after must be equal to each other, we can use the elastic collision equation m1v1 plus m2v2 is equal to m1 plus m2 times vf. Based on what we know from the problem, we can replace our values for mass and velocity to solve for our final velocity, which is equal to 399 over 101 or equal to 3.95 meters per second.